The Fermi Paradox, a failure of arithmetic, not a mystery of the universe. There are hundreds, if not thousands, of videos on the Fermi Paradox. Great filters, zoo hypotheses, dark forests, simulation theories, entire careers built on a single question. But what if the question itself was never valid? What if the whole thing collapses under 30 seconds of basic arithmetic? Let's find out. Enrico Fermi died in 1954. His famous question, "Where is everybody?" was asked casually over lunch at Los Alamos in 1950. It wasn't a paper. It wasn't a formal argument. It wasn't published. It was an offhand remark during a conversation about UFO sightings and a New Yorker cartoon. Now let's look at what Fermi actually had available to analyze the universe. 0 confirmed exoplanets. The first detection of a planet outside our solar system didn't happen until 1992. 0 satellites in orbit. Sputnik was 7 years away, 1 radio telescope, and that was Grota Reber's backyard dish from 1937. The confirmation that galaxies are even external to the Milky Way was only 25 years old. Fermi was extrapolating from a sample size of 1 biosphere, using instruments that could barely resolve surface features on Mars, let alone detect biosignatures on worlds orbiting other stars. And from this, we built a paradox. The inverse square law is merciless. A broadcast signal radiating in all directions loses power proportional to 1 over the distance squared. A powerful television station broadcasts at around 1 megawatt. By the time that signal reaches even the nearest star system, Alpha Centauri, at 4.3 light-years, it has spread across a sphere so vast that the power per unit area is buried deep beneath the cosmic background noise. The practical detection range for a typical civilian broadcast, even using the most sensitive radio telescopes humanity has ever built, is roughly 1 to 3 light-years. That's not even halfway to the nearest star. The Milky Way is 100,000 light-years across. Our broadcasts are functionally invisible beyond our own backyard. Even Arecibo's focused 1 megawatt beam, the most powerful deliberate transmission we ever made, was detectable to maybe a few hundred light-years under ideal conditions. That covers a fraction of a percent of the galaxy. Now let's talk about power. The sun outputs roughly 3.8 times 10 to the 26th watts. A powerful television transmitter outputs about 10 to the 6th watts. That's a difference of 20 orders of magnitude. We can barely detect the stars themselves at galactic distances with precision. The idea that we detect a signal 20 orders of magnitude weaker, radiating in all directions, from a planet we haven't confirmed exists, orbiting a star whose position we're observing thousands of years out of date. It's not a paradox. It's a failure to do the arithmetic before asking the question. Expecting to detect an alien broadcast is like expecting to see a candle taped to the surface of a star from the other side of the galaxy. Here's something people almost never consider. The sky you see at night is not a snapshot. It's a temporal composite. Every point of light is a different age. Look at Orion's belt. 3 stars that appear to sit in a neat row. Alnitak is about 800 light-years away. Alnilam is about 1,340 light-years away. Mintaka is about 915 light-years away. They're not together at all. They're separated by hundreds of light-years in depth. The light arriving from Alnilam left over 500 years before the light from Alnitak. You're looking at a temporal composite spanning over half a millennium, just within 3 stars. Stars aren't where we see them. Any signal arriving from a distant star is coming from a location the star no longer occupies, transmitted by a civilization at a technological stage that is thousands of years out of date. You're not observing the galaxy as it is. You're observing a smeared composite where every point is a different age. And from this, we declare the galaxy silent. The electromagnetic spectrum is effectively infinite in terms of where a signal could be placed. When SETI searches, they typically focus on narrow bands around frequencies they consider natural choices. The hydrogen line at 1,420 megahertz, the so-called water hole. The assumption is that any intelligent civilization would reason the same way and pick a universally obvious frequency. But think about how parochial that assumption is. It assumes alien physics education emphasizes the same spectral features ours does. It assumes they'd reason about communication the same way. And most fundamentally, it assumes they'd use electromagnetic radiation at all, rather than gravitational waves, neutrino streams, or something we haven't even conceptualized yet. We're tuning into one station on a radio with 1 billion channels and concluding nobody's talking. Humanity started high-power omnidirectional broadcasting around the 1930s. We're already transitioning away from it. Cable, fiber optics, low-power cellular, tightly beamed satellite links. The period during which Earth is electromagnetically loud in an omnidirectional sense might end up being roughly 100 to 150 years, out of a civilizational lifespan that could span thousands or millions of years. That's a detection window so narrow that even if two civilizations existed simultaneously in the same region of the galaxy, the odds of their loud windows overlapping are vanishingly small. Earth is already going quiet. We are not even a good example of a detectable civilization. So here's the honest version of the Fermi Paradox. Given that we have almost no ability to detect extraterrestrial civilizations with current technology, it is entirely unsurprising that we haven't detected any. Our broadcast detection range is about 3 light years. An alien transmitter is 20 orders of magnitude weaker than its host star. Our loud window is maybe 100 to 150 years, and the number of frequencies we'd have to monitor simultaneously is effectively infinite. Nobody builds a career on that sentence, but that sentence is the truth. The Fermi Paradox persists because it feels profound. Great filters, zoo hypotheses, dark forests, simulation theories. All of them are elaborate philosophical structures built on a foundation that a back-of-envelope calculation demolishes in 30 seconds. We can't detect anything because our instruments are hopelessly inadequate for the task, doesn't generate 1,000 follow-up videos. Maybe advanced civilizations destroy themselves does. Maybe they're hiding from each other in a dark forest does. Every one of those speculative frameworks assumes the detection problem is solved and then asks why the mailbox is empty, when the real answer is that we haven't built a mailbox yet. The whole thing is a monument to substituting narrative for numeracy. A man standing in a dark room with a candle, unable to see the walls, declaring it strange that nobody else appears to be in the building.